Okay, so today we are beginning section 6, and we're going to be solving other types of equations. So far in chapter 1 we did linear, and then on the quiz yesterday we covered quadratics. So now we're going to see other types of equations in section 6. Today we're going to specifically see rational equations. Now, to just review about fractions. Remember when you have a fraction that the denominator of your fraction can never be a 0. So when we're solving our rational equations, if our solution would make the denominator a 0, we're going to get rid of it and we're going to say that there's no solution for it. So remember, a 0 in the denominator of a fraction makes that fraction undefined. So just remember that. And this is why what we're going to do here is we're going to have to find the values of x that we're going to exclude that would make the denominator a 0. Yes?
What would make no solution 0 over 1?
No, I'm going to show you what I mean by that. Okay, so let's go ahead and let's look at our first example. So what we're going to do here is we're going to first look to see what values of x would make my equation have a denominator of 0 once I get my answer. So I'm going to go ahead and add a 1 to this one. So the first thing I'm going to do is look at all the bottoms of my fractions. Notice the first one has a 4. That's not going to change. That denominator is going to stay a 4. The middle one, though, what number could I put in for x that would make that denominator become a 0? -1. And the way that you would do that is you could do x plus 1. If you can't just see it, you set it equal to 0 and solve for x. So you can see that if x is -1, if after you do the problem, that would make this denominator become a 0, which would make the whole problem undefined. Then the last fraction has a 1 in the denominator, so we don't have to worry about that. So the only number that once we solve our problem, if it ends up being x equals -1, then my answer is no solution. So this is my little disclaimer that x could be any number except -1 once we do this. So let's go ahead and try and solve our problem. So the first thing we need to do is find a common denominator. And my common denominator here is going to be 4 times the x plus 1. Everybody with me on that? Because this has a 4, this has the x plus 1, and this just has a 1. So the denominator that will be in common is 4 times x plus 1. So what I'm going to do, let me rewrite my problem here. So I'm going to take my 4x plus 3 over 4 minus 2x over x plus 1 equals x over 1. So now what I'm going to do is I'm going to take my entire equation and I'm going to multiply it by that common denominator. So I'm going to distribute it to all 3 things. So notice the first one, when I distribute it to the 4x plus 3 over 4, the 4's cancel. So like when I distribute it here, these cancel, and then I'm left with multiplying x plus 1 to the 4x plus 3. You can also think of it as I'm trying to find a common denominator. What is the denominator missing? The next I have to do is distribute that to the second fraction. So now I'm going to distribute it to here. And again, get rid of the cross. So now here, when I distribute it there, notice this time the x minus 1 cancels out. Put that back in red. So now this cancels. So then the only thing I need to multiply is 4 times that negative 2x. And then the last fraction is missing the whole thing. So I need to multiply x times the 4x, 4 times the x plus 1. So then 4 times x is 4x, and then x plus 1. So now I have to FOIL the beginning and multiply. I'm just going to multiply the whole thing. So the first multiplication is a FOIL problem. So I get 4x squared plus 3x plus 4x plus 3. Then I'm going to multiply these two and get negative 8x. On this side of the equal sign, I'm going to distribute. So notice I have some like terms here, the 3x and the 4x. So I can add those and a negative 8x here. So I get 4x squared. 3x plus 4x is 7x, minus 8x is negative 1x. And then I still have the plus 3. So now that I've combined all like terms on the left, nothing to combine on the right, now I can start grouping things together. So I'm going to try to move my x squareds together. Notice the 4x squared cancels on both sides. Next, I'm going to move my x's together. You could have moved the 4 over and then moved the 3 back over. Doesn't really matter. You're going to get the same answer either way. Then divide by 5. And I found my value of x to be 3/5. Now, I'm going to go back to where I had to find out what x couldn't be. And the value that x could not be was negative 1. So because 3/5 is not negative 1, this checks. It works. That's my solution. So remember, whenever you're solving for a variable, the value you get, remember, you can plug it back in to the original problem to see if it makes sense algebraically. Okay, so once you plug it in, it should equal 3/5. If it does not, then you've done something wrong. In this particular case, it's going to be 3/5 because if you notice, your equation was equal to x. Let's try another example so we can get the hang of this. Here's my next example. This one's a little simpler. What is going to be my common denominator? The x minus 4, right? So this one is the only one, the last number in the problem is the only one that needs the denominator. But again, I have to multiply the whole equation by the x minus 4. So when I do it to the first one, it cancels. So I just write the numerator. When I do it to the next one, it cancels again. So I just write the 4. But this one, there was nothing to cancel with, so I've got to distribute it to the 4. So now I'm going to distribute the 4 and combine my like terms. I can group the 4 and the negative 16 and get negative 12. I then have to move the 4 over and get negative 3x. Divide by negative 3. And I get x equals positive 4. I need to check it. Okay, so when I go back up to the top, remember my common denominator here was x minus 4. Let's see if 4 would be a good solution. It's not looking good. So if my solution ends up equaling 4, my answer is no solution because it would make the denominator of the fraction 0 when I plug it in. So remember, here's your original problem. X over x minus 4. Just plugging it into this very first fraction, notice you get 4 over 4 minus 4. What's 4 minus 4? 0. So as soon as it makes one of the fractions a 0 in the bottom, then you know your problem is undefined. So this solution is not a valid one because it makes the denominator a 0. So the answer to this problem is no solution. So in this case, in these types of problems, the check is mandatory for the denominator. You must check to see if your answer makes the bottom of the fraction equal to 0. If it does, get rid of that answer and put no solution. Now, when we get to a quadratic one, we're going to have two solutions. One of them may work, one may not. They both may work, or they both may fail. So you're going to see all different types of answers here. Sample 3. I need to find a common denominator. But before I can even try to, I need to factor that last fraction. Because I don't want to list my common denominator as x minus 2, x plus 2, and x squared minus 4, because pieces of the denominator might already be there. So I'm going to factor this into x plus 2, x minus 2. It's the difference of two squares. Notice the first two fractions already have a little piece of it. So I can already see my common denominator is that x squared minus 4. But I'm going to write it as x plus 2, x minus 2. So now, to start to figure out the common denominator, I need to multiply the entire equation by x plus 2, x minus 2. Notice my first equation, the 3 is only going to get distributed to the x plus 1, because that's what it was missing. Then the middle one, the 1 is going to get distributed, you really don't need to even show it, to the x minus 2. And then the 12, it already had both of them, so you just write the 12. I now need to distribute the 3. 3 to the x, 3 to the 2. When I distribute it to the 1 to both of those, it just stays the same. I now need to go back and combine my like terms. So I'm going to add the 3x and the x. That will give me 4x. Then I'm going to add the 6 and the negative 2, which gives me 4, and then rewrite the rest of the problem. Now I'm going to solve for x, so I'm going to subtract 4. 4x equals 8, divide by 4, and I find that I think my answer is x equals 2, but remember, we got to check it. If it makes any of the denominators a 0, we throw it away. So again, my denominator, remember, is x plus 2 and x minus 2. Set them both equal to 0. So for this one, I can see when I subtract 2, x can't be negative 2. And on this one, x can't be 2. But look what I got as my answer. I got a 2. So since it can't be a 2, my answer is no solution. So if it makes the denominator equal 0 when you plug it in there, then you put no solution. This is not a valid answer. It would make my problem undefined. Everybody good? Let's try 4. This one's going to be, still same thing. No quadratics yet. But we got some bunch of factoring problems to do first. All right. Always remember when you're looking for a common denominator to factor it first. So I need to factor the first fraction. I'm looking for two numbers that will multiply to give me negative 2, but will add to give me 1. And that is going to be x plus 2 and x minus 1. The middle one is the difference of two squares. So x plus 1, x minus 1. And then the last one, always, 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 before you begin, you should always look for a GCF first. So I can actually factor out a 2 first. And then I get x squared plus 3x plus 2. Factors of 2 that give me 3 are going to be 2 and 1. All right, so now instead of having a huge denominator, I'm only going to pick the things that appear in everything. So my common denominator here is going to be, I've got an x minus 1. I've got an x plus 2. I've got an x plus 1. I haven't written it down yet. I've already written this, so I don't write it again. I need a 2 out front here. I've already written the x plus 2, and I've already included the x plus 1. So my common denominator is going to be this. This is what I'm going to multiply my entire equation by. So now I'm going to rewrite the problem, and instead of putting the original problem, I'm going to put what was factored. So I'm going to write the common denominator over here, because this is what I need to multiply it by, my whole equation. And now I'm going to write the original equation, but with the denominator factored. And you know what, I'm going to move the negative up to the top just to make it easier for when we distribute. And then equals 7 over 2 x plus 2 x plus 1. Okay, so now I'm going to multiply that entire denominator in red to that original equation. So notice on the first one, you can either think of the x, you can either think of it as canceling out. So for example, this and this and this and this. So the only thing that's left now are the 2, thank you, the x plus 1 times 3. So all of this is going to get multiplied to the 3. So I'm going to do 2 times 3. I'll make it 6 times x plus 1. Everybody with me on that? All right, next one. Let me see if I can erase the highlight. And then I'll put it back. Okay, so for here, now I have 6 times x plus 1. So now for the middle one, what it's missing, or I could cancel out just to show you, this one and this one are already there. So now the negative 1 is going to multiply to the 2 and the x plus 2. And that's what that middle term will be. Let me get rid of the stuff and I'll put it back. And then the last one, the only thing that it's missing is the x minus 1. Because it's got the 2, it's got the 1, and it's got that 2. So 7 times x minus 1. So now I need to distribute and combine like terms. So I'll distribute the 6 to the x, 6 to the 1. Negative 2 to the x, negative 2 to the 2. 7 to the x, 7 to the negative 1. I'm now going to group my like terms. Notice I have some like terms here with the 6 and the 2, so that will give me 4x. Then I can group the 6 minus 4, and that will also give me plus 2. Over here, nothing to group, so let me just rewrite the 7x minus 7. I now need to get my x's together and my numbers together. Doesn't matter which. I'm actually going to move the red 4 to the 7. Technically, it doesn't matter. I could move it the other way. I just get a negative 2. I wrote the wrong thing. That should be a 4. And then I get 3x minus 7. Add the 7. and I get 9 equals 3x. Divide by 3, and x equals 3. Remember now, we've got to do the check. So let's go back up and let's look to see what would make the denominator a 0. So remember my huge denominator I found? This whole red thing. So 2 equals 0. I don't need that because there's no variable to solve for. But then the next piece of it was the x minus 1, then the x plus 2, then the x plus 1. Solve each of these, and I can already see that none of them are going to give me a 3, so I know my answer is going to be good. But just to show you, finish it off, x can't be 1, x can't be negative 2, and x can't be negative 1. So if you were to solve each one of the pieces of the denominator, x cannot be positive 1, negative 2, or negative 1. Because if it is, it would make the denominator a 0, and it would make my equation undefined. But because when I solved my problem, I got x equals 3, this is a good solution. So it checks out. So we need to factor the denominator first to figure out what our common denominator is going to be. So when I factor the very last one, that's the only one that needs to be factored, notice I get x times x plus 1. Notice the first two fractions have a piece of that. So right there in that last fraction is my common denominator. So I'm going to multiply my entire equation by the common denominator. So my first fraction, notice that the x plus 1s will cancel. So I'm just going to multiply x, because that's the only thing it needs, to the 4x plus 3. The middle fraction, it's missing the x plus 1. And the last fraction has everything it needs, so you just write the 1. It already has the common denominator. I now need to distribute. 4x squared plus 3x plus 2x plus 2 equals 1. Simplify and combine any like terms before you begin moving things around. I can group those. It gives me 4x squared plus 5x plus 2 equals 1. I now need to move the 1 over because I need to make my equation equal to 0. Now, if you were doing completing the square, you'd move the 2. But I'm doing factoring, so I'm going to move the 1, and I'm going to make my equation equal to 0. Now I have a trinomial that can be factored. So I'm going to look for the factors of 4 that will give me 5. So 4x plus 1 and x plus 1. So if you do guess and test, if you do the trick, whatever method you're going to do to solve that, if you're using the factoring method, FOIL that. Make sure it does go back to this. Otherwise, you might have factored it incorrectly. All right, but mine is correct. I'm just going to go ahead and set each one of my binomials equal to 0. So 4x plus 1 equals 0, and x plus 1 equals 0. I'm going to move the 1, divide by 4. X equals negative 1/4. Over here, move the 1. X equals negative 1. I now need to do my check and make sure that these are both good solutions. Now again, they could both work, they could both fail, one could work, one could not. Anything's possible here. So let's go back and let's take a look at our denominator to see if any of these would make it 0. So notice, remember my denominator was x times x plus 1. I'm going to set each piece equal to 0. So first this one, and then this one. Notice my two values that x cannot be are -1 and 0. And notice one of my answers that I got was -1. So this one gets thrown away, and this problem only has one valid solution. Now you're not going to say no solution and -1/4. You're only going to list the -1/4 as your solution. All right, so just to show you, let's say we solve this quadratically. So we would get 4x squared plus 5x plus 1. My A is 4, my B is 5, my C is 1. So opposite of B, plus or minus, B squared minus 4 times A times C, all divided by 2 times A. And then -5 plus or minus 25 minus 16 over 8. -5 plus or minus the square root of 9 over 8. -5 plus or minus 3 over 8. And then -5 plus 3 over 8. And then I'm also going to do -5 minus 3 over 8. So here I would get -2 over 8, which would be -1/4. Over here, -8 over +8, which is -1, which is the exact same solutions I got when I did it with factoring. So again, it's not going to matter. This is why yesterday I told you when the radical goes away, you need to figure out the numbers. So we're going to have to see what the solutions are and if they would make the denominator 0. So in this case, same situation. The -1 gets thrown away, and the only valid solution is x equals -1/4. So again, you could have also done completing the square. So choose the method you're most comfortable with. Now, factoring may not always work, so you may have to resort to completing the square or quadratic formula, because you may end up with a radical. One last example. So again, we need to find a common denominator here. So I could add a 1, and notice my common denominator is actually going to be 2x minus 3 squared. Because the first one doesn't have either of them. The middle one has one of the 2x minus 3's, but the last one has 2 of them. So my common denominator is 2x minus 3 squared. So the first one needs the whole thing. So 6 times 2x minus 3 squared. The middle term has one of them, so I only need to times it by 1 2x plus 3. Minus 3. And then the last one has everything I need. Now, for the first one, that's 6 times the 2x minus 3 squared, I need to follow order of operations. So I need to do the exponent first. So I have to FOIL it. So 2x minus 3 times 2x minus 3. Once I get that answer, I'm going to distribute the 6. So I get 4x squared minus 6x plus 9. I'm going to group my middle terms, and that gives me a -12x. Then I have to distribute the 6. So I get 24x squared minus 72x plus 54. Now over here I'm going to distribute the 7. 14x minus 21 plus 3. I can group the 21 and the 3. It's a -21, so a -18. Let me just drop that on down here. Now I can begin to get my x's together and my constants together. So I need to move the 14. And I also need to move the 18. Just going to do it together here. I'll just do it in a different color. So now my equation is 24x squared minus 86x plus 72. equals 0. So now, I need to first look for a GCF. You should always, whenever you're doing any of these problems, look for a GCF first. This one I can actually divide by 2. So once I make it smaller, divide by 2, and I get 12x squared minus 43x plus 36 equals 0. At this point, I can't pull any more GCFs out. I need to use one of the methods in section 4. I either need to factor this, use completing the square, or quadratic formula. I'm going to factor again. I know the numbers are kind of large, but it's factorable. So the factors that I can come up with are going to be 3x minus 4 times 4x minus 9. This will FOIL back to my original trinomial. Now, if you're not good at factoring, you can do quadratic formula. Just know you're going to be multiplying really big numbers. So here, now that I factored it, I set each piece equal to 0 to get what x equals. So I'm going to first take this piece, 2 equals 0, which there's no variable here, so that gets thrown away. If it were a 2x, x equals 0 would be one of my solutions. So 3x minus 4 equals 0, and then the 4x minus 9 equals 0. I need to solve, so I add 4. 3x equals 4. I'm going to divide by 3. X equals 4 over 3. Add the 9. 4x equals 9. Divide by 4. X equals 9 over 4. I now need to check them. These are the possible answers. So I'm going to go back and I'm going to set each one of my denominators equal to 0. But what was nice here, it was really just, it looked like it was complex, but it's just really 2x minus 3 squared. So I just need to do one of them. So 2x minus 3. Divide by 2. X cannot be 3 over 2. Notice my two fractions, neither of them are 3 over 2. So both of these check out. I have two solutions to this problem. Someone in my other class had asked me, what if you would have gotten 6 over 4? Do you have to simplify that and make it 3 over 2? Yes, you do have to simplify your answers. So if you get something that needs to be reduced, reduce it. 6 over 4 is the same thing as 3 over 2. So if this were one of the answers, it wouldn't work. So always simplify. So this one has two solutions, and they both are valid solutions. They do not make my equation undefined. So your homework is page 144, 7 through 25 odd. Tomorrow we will continue on with section 6. Tomorrow we will do square root equations. So that is it.